Hello. A few months ago I uploaded some videos to YouTube where I had my quadcopter autonomously moving around following me, or rather following this tag. I'm calling it a tag. And this was broadcasting its location to an Arduino on the quadcopter, which was communicating with cleanflight to tell it where to go. And it was also turning the camera gimbal, 3-axis gimbal, so it had yaw and pitch control, and the camera was being maintained, or the direction of the camera was maintained to point at the tag as well. And the only thing I put in the description of those videos was details to follow, because it's a pretty complicated thing, and I didn't want to have too many questions all coming at once, and the code was a bit of a mess, and not all of it was working very well. But fast forward to today, and now the code is still a mess. It's better than it was, but it's tidy enough that I think I can put it up on GitHub, and maybe some other suckers for punishment out there will be interested to give it a try. So this video is going to be explaining some of the steps. Well, I've tried to, let's have a look at the GitHub. I've tried to explain everything on here as well as I can, but some of it's better explained by video, so I will, I think I'll just let you read this. Last time I did a video like this, I went through all of the text on the GitHub page and basically looked through each step of it, but I'll just let you read this. There's probably not that many people that are going to be interested in trying this anyway, so I'll just let you read that, and I'll go over in sort of a parallel instruction here in the video, just looking at the things, the actual, hardware that I've made. One thing I will just point out the very first part. There are 3 sketches involved here. You don't need to use all 3 of them. You only need 2 of them. So obviously you need the follow me tag, which is the thing that you're going to carry around to be the target of the movement and the camera angle. And then the follow me controller is going to ride on the quadcopter and talk to cleanflight to do the autonomous control. And this other one here, follow me checker, is something that I had around that I found very, very useful over the last year or so doing Arduino projects with the nRF24 modules. And it just sort of prints out all the information that the follow me tag is broadcasting over the radio. So it's just a helper to let you know what's going on, but I would highly recommend, if you're doing any projects with nRF24 modules, just set up something like this. You'll use it a lot in the future, I think. So the point is that only these first 2 sketches are necessary to do what we're going to talk about. So the follow me tag is this one here, and I've tried to keep it compact, and so you could sort of strap it onto your shoulder or on top of a helmet, motorbike helmet or a ski helmet or something like that. I'm not sure if carrying it in your pocket would be too great, because there's a GPS in here and you sort of want to let that have a good view of the sky. Originally I had a smaller battery inside that I ruined, so that's why I'm using this larger one outside. This is a 900 milliamp hour 3-cell, one cell, sorry, what am I talking about? 900 milliamp hour 1-cell battery. It lasts for ages running this. So let's have a look inside. And I think I did briefly look at this one time in the past. But what we have in here is an Arduino Pro Mini. I think that's a 3.3 volt one, that one. Yeah, it must be, because there's no voltage regulator in here. So the 3.3 volt Arduino Pro Mini, and there is an MS5611 barometer. They are connected by an I2C connection. So this being a fairly advanced sort of a undertaking, I'm not going to explain a whole lot of details about where all the wires go. I expect that if I say I2C, you should know how that's connected. I have listed it in the sketches, of course, but I'm not going to explain things at that level of detail. So the barometer talks to the Arduino by I2C, and then underneath that I have with the antenna there is a nRF24 module there, and that's of course using SPI. And I have a couple of capacitors on there across the power for these. Probably not really necessary to have two, but it's been working really well with those two. I think one's a 10 microfarad and one's a 0.1 microfarad, and that works really great. I just have a little switch here to turn it off and on. I just use the number 1 switch of that to do that. And then down here I have a U-Blox, or U-Blox compatible, I think. I'm not sure if it's an official one. And this is a Neo 6 series, so you don't need to have the 7 or anything newer. Like a couple of my other sketches that I've uploaded were made for the 7 series, and people have been asking me questions about why it doesn't work with their Neo 6. But this one will work with the Neo 6, so we shouldn't have any problems like that. And this is a serial connection, so we've just got the RX and TX there, and power of course. And this GPS module I have runs quite well off 3.3 volts, so I've been able to just connect this directly to my Arduino VCC for power. And you'll notice that it's going on to the RX and TX pins of the Arduino, so it's using hardware serial, and that's necessary to get the data in from the GPS fast enough. If you use a software serial, the data just comes in very intermittently. It's not very reliable. So one of the down points with connecting to the RX and TX pins like that is that when you power it up, the GPS is going to be talking to the Arduino, sending it information. So if you want to connect your computer, or you want to upload the sketch onto your Arduino again, it won't work. Most likely it won't work. So I've found that whenever I want to upload the sketch onto the Arduino, I have to disconnect the RX pin, I think. One of them anyway. I think it's the RX pin you need to disconnect, just temporarily, to upload the sketch. So not too much more to say about this. The barometer ideally would be better shielded from the wind and the light than what I have done here. I do have this little piece of fluffy stuff that I put over it when I close the lid, just to shield it a bit better from wind, but I have noticed that it does sense when it is in strong sunlight or weak sunlight or overcast, under the cloud. So that's why I have that black marker pen scribbled on there to try and mitigate that problem, but even so, it still does manage to sense when the sunlight is, when it's brighter. So ideally the barometer would be in a pitch black box, but it doesn't seem to be too much of a problem. So that's the tag, and the tag is continuously broadcasting the latitude and longitude and horizontal velocity, so that's velocity north and velocity east, and the altitude coming from the barometer, and what else? Yeah, that's all. So it's just continuously broadcasting that over and over and over as fast as it can, and that's all it does. And like I say, with the 900 milliamp hour 1S battery like that, it lasts for ages. So over here I have the checker, and this is the part that's not really necessary, but I made this thing ages ago and I've been using it for a lot of other NRF24 projects, and it's been really handy to have this around just to quickly throw a different sketch on and check that the data that I'm expecting to be sent is actually being sent before I try and do something more complicated on the receiving end with the actual follow me sketch. So this one has, again, a Pro Mini NRF24 module, and you're going to need some kind of a screen to see what the data is, and I'm using one of these I2C, the little OLED screens. These screens are really handy, and even though this is a I got a bit lucky with this, I think. I didn't realize for a while how lucky I'd got, but this is a 5-volt Arduino, and this NRF module here is supposed to be powered by no more than 3.3 volts. It's actually, if you look at the spec sheet, it says that ideally it should be about 3 volts if your signal inputs, like your SPI signal wires are giving 5 volt signals. But what I've done here is I'm powering it from a 1S LiPo that's about storage charge, so that's about 3.7 volts. And just luckily that all seems to work. So it's not the ideal voltage for either of these things, but still hasn't given me any problems in about a year and a half. Right, so when I turn this on, we'll see that every few seconds it switches between two different sets of information. So first thing at the top is how many drops. This used to be a number counting up to say how many packets it had missed, but it wasn't really important to know how many, so I just left it at 1, which means that it's every time it's tried to receive something, it failed. And the PPS below that is packets per second, and that's obviously 0 because our transmitter is not on. And then we have velocity north, velocity east, and lat long and altitude. So they're all 0 at the moment because the tag is not on. So let me just turn the tag on and we'll see how these change. So I'm just going to turn this little switch, it's a bit fiddly, and then quickly pick this up again, and then we'll see packets per second goes up to around about 50 briefly, and then it'll drop down to 0, and then it will come back up, and the second time it comes back up we'll see that there's actually a valid altitude number now. So the reason it drops down to 0 briefly at the beginning is because it's doing some calibration of the barometer to figure out what, so this altitude that I have it sitting at on the desk, it's going to consider this altitude to be 0, and so it thinks it's 1 centimeter above the desk at the moment. And if I raise it above my head, you should see altitude goes up to about a meter or 100 centimeters. There you go. And if I lower it, it should go, below. It's kind of annoying how that keeps changing, isn't it? Okay, so now it's 26 centimeters below the desk. So this lets you know that the altitude reading is coming in correctly. Interestingly, we get, oh, this is 50 packets per second. Yeah, I found that when I place this, watch how the packets per second goes down when I place the tag on the desk. It goes down to about 30. Wow, 20 something there. I think it's the reason is that the antenna is flat along the desk. If I lift it up just a little bit above the desk, so now it's about a centimeter above the surface of the desk, now it goes back up to 50 packets per second. Interesting, eh? Anyway, that's kind of beside the point. But you should be seeing around about 50 packets per second, I think is the most I've ever seen, maybe 52, 53 or something like that occasionally. Alright, so at the moment there's no lat long coming in, and there's no velocity north and east, because these are the numbers that come from the GPS module, and I'm inside at the moment, so probably not going to be able to pick up any signal from where I'm sitting at the moment. Incidentally, the M8N module picks up signal quite well from where I'm sitting right now, but this is not such a sensitive GPS module I have in here. So let me go and I'll put this outside, and then we'll see how that affects the numbers coming into here for my velocity and lat long. Okay, so I've just put the tag out on the veranda. Still nothing coming in yet. The signal has to go through quite a few walls now to get here, so we're only getting 10 or 11 packets per second, but it should have some decent GPS reception now. Okay, there we go. So that is, now you can see the velocity numbers changing, so these are centimeters per second. So a value of a 1 or 2 means it's basically not really moving. But you should expect to see something changing there. And then there's the lat long as well. Okay, so that's all that this tag does. Oh, and of course drops 0 is what you should expect to see when it's running properly like that. So that's how the tag works. Yeah, it's really, really helpful. Let me say it again, it's really, really helpful to have something like this. And if you ask me questions like, oh, I can't get it working, what's going on? First thing I'm going to say is, make one of these if you haven't already, because that'll probably answer your questions quite well right off the bat. So the next part is the follow me controller, which is on here. And for this, we actually need less parts than the other two things. Well, you can, if you use a screen, you'll need about the same number of parts as the checker, but the minimum necessary parts to use this is just an Arduino and an NRF module. So let me just bring this down a little bit more. So this little piece of plywood is actually, I took this out of the YMFC flight controller that I had for one of my wooden quadcopters at the beginning of this year. So it has an Arduino Pro Mini 5 volt. This one really has to be a 5 volt one. I originally started using this with a 3 volt one with a level shifter to talk to the cleanflight, and I couldn't get it working at all. And everything came right as soon as I started using a 5 volt Arduino, so that it's sort of at the same logic level as the flight controller. Flight controller is over there. That is a Flip 32, and of course it goes without saying, I think, that maybe I should have mentioned at the beginning, but to do this you're going to need a quadcopter that's set up and using cleanflight iNav specifically. I don't know how many of the cleanflight iNav changes have made it into the regular cleanflight yet, but I know that this will work with the iNav branch or fork of cleanflight, and probably not with the regular cleanflight, and definitely not with Betaflight or anything like that. So anyway, you'll need to have a quadcopter that's set up to do autonomous stuff like return to home and position hold and things like that. Anyway, so back to the controller. So being a 5 volt one here, I have had to use a little voltage step down regulator to power the radio module. So this is again at 3 volts. And I think I did actually set this one to 3 volts, not 3.3, because if you're using 5 volt signals, according to the datasheet again, you should be powering it with 3 volts instead of 3.3. Anyway, so that's the antenna there, just goes down there. Again, a couple of little capacitors on there seem to work quite well. Over here in the top corner I have an accelerometer, but that's only on there because, like I say, I took this out of the quadcopter that I was using at the beginning of the year, so that's not really necessary. I just have it disconnected there. Alright, and we have some wires coming up here. Let's look at these two wires here. So we've got black and white are ground and VCC, and then there's a couple of wires there which are a little bit hard to get at, but they are these ones there, blue and the green one, and they are making their way up to here at the top. So at the top I have another one of these OLED screens, and this is the piece I was saying is optional, but again, if you don't have this, you're going to be pretty clueless as to what's going wrong if you have problems, and I'm probably not going to help you much if you don't have this on there to at least get some feedback about what's going on. So that's that one, and then there are 3 other wires here, and this one's coming from ground, and these 2 are coming from, in my case, pins 5 and 6. I preferred to have them 3 and 5 because these are the faster PWM outputs 3 and 5, but this pin here is, my pin 3 is going a bit strange. I can't solder onto it properly. It seems to be, I don't know, it just doesn't take solder. So I'm using pins 5 and 6, but I've made the sketch to use 3 and 5. And if we follow those over, the blue and the purple one go all the way around here. And this is a bit awkward to try and show you, but if I turn this carefully, we'll see that those are going into the gimbal control board at the top of the gimbal, and those are used to direct the gimbal pitch and yaw so that the camera points at the tag while the quad is flying. Of course, you don't need to have a camera gimbal to do any of this. It's just gives you a nicer result if you do. Right, so let's power this up and see what we can see. Oh, another thing I didn't mention is that there's a little LED on pin 2. So this is just ground and pin 2, and then there's a small resistor between them so that it's not just, you know, too much current going through there. Just a current limiting resistor, that's what it is. Alright, so if I power this up, and I've left the follow me tag outside on the veranda. It's still running, still broadcasting. So first thing we notice is that the LED is blinking off and on, and it turns off or on, it toggles every time it receives 5 packets from the tag. So this lets you see, it's kind of like a heartbeat to see that there is radio packets being successfully received from the tag. Oh, okay. And you can also see roughly how many or how fast they're coming in by the speed that this changes at. So it's probably about, what was it, like 10 packets per second or something before? It'll probably something like that at the moment. Okay, probably more interesting though is the screen. Let me just get this in view. It's a little bit awkward to see with that sellotape on there. Alright, so here we have, again, packets per second is around 50. Oh, that's good, isn't it? And then the RC is the current value of the roll stick of your transmitter. So some of this information is coming from the radio out on the veranda. Some of it is coming from CleanFlight itself. So let me just see if I can keep this all in view. I don't think I can. Oh well. So I'll just turn my radio on, and let me just put this here. Oh, this is awkward. Okay. Now we're going to lose focus, aren't we? Alright. So you see the number RC5 in the top right. This lets you check, if I move my roll stick to the right, it should go to 10. It's a little bit slow to react. But when it's in the middle, it should be 5. And if I take it all the way to the left, it should be 0. So this is, it's just to let you see that information is being pulled from the CleanFlight controller successfully. But that's only one piece of information. We can see also their altitude. Just turn that off. So there's 2 numbers for altitude. One is the altitude of the quadcopter, that's the one on the left, and then the one on the right is the altitude of the follow me tag outside. So I guess the veranda is a little bit lower than when we have the desk. And the important point to note here is that when you turn each of these on, they should be at the same altitude so that they both record the same altitude as 0. because some of the flight modes, the quadcopter will try and put itself at a certain altitude above the tag. So if they're not both started at the same altitude, to record 0 the same might not work out too well. After that we have yaw, and again there's two values. So yaw, the left one is the yaw of the quadcopter. Well, it's actually heading, but heading's a bit long, so I just called it yaw, just to save space. So that means it's heading 21 degrees. So if I turn it a little bit to this way, I should be able to get it to face due north. I lose focus. Alright, so around about there. So now the quadcopter is pointing due north. So that is north. The second number, in this case minus 69 at the moment, is the angle that the camera gimbal needs to be turned to point towards the follow me tag. So these numbers sort of work together. So you can see if I put it to, now they're 1 and minus 69. If I move it to here, then now it's 0 and minus 68. So they're always going to be 68 apart for the current position of the quad and the follow me tag. So if I go around here, we get it to 10, now it'll be 10 and 78. Well, minus 78 that is. So what that's doing, that minus 78 degrees, is telling us, see the camera gimbal move? This is another way that you'll be able to tell whether everything's working okay, is that you should see this pointing towards your follow me tag. It's not going to work very well at the moment because the quad is indoors, and like I say, this GPS module, being an M8N, is quite a good one, so it does actually pick up a decent GPS signal even inside, but it's not going to be very accurate. So at the moment it's the follow me tag is more like about over this direction, not that direction. But the point is that as you move the quadcopter around, the camera should maintain the same direction. So it's pointing pretty much directly towards me at the moment. Well, not quite, but it's so the camera is pointing in this direction along this line, and if I turn it around, it should go back to that position each time, like that. And it's a bit slow, you'll notice, because it has to react to how the quad's moving. And it doesn't know where to go until the quad moves somewhere. So it can only follow after what the quad does. Which is a bit unfortunate, because sometimes the quad turns quite quickly and the camera lags behind a lot, like that. And you'll see this in the video that I'll show you in a bit. But it's not very pleasant to watch. But the reason that happens is because the gimbal is kind of made to smooth out these movements, and it's set to pan mode for yaw at the moment. Anyway, so it's probably enough about that. You'll notice one thing down here that we'll see in the video as well. I had a problem with this gimbal in that all of a sudden it was working fine. I used it for about 2 or 3 hours, well, not that long, a few flights, and then all of a sudden I found that when it got to 45 degrees or so over in this direction, so when it turned itself to about there, it would just lock itself rigid and stop working. And it turned out to be I2C errors. And with a bit of investigation, I found that it was to do with this wire going through the yaw motor. It was having trouble. The signal just wasn't clean enough to read properly. So what I've done here is I took one of these same kind of wires off one of the other gimbals that I had that got a bit broken, and I connected this wire up directly from the from the gimbal controller board to the IMU on the bottom of the gimbal plate, at the right underneath the camera, and it's not going through any of the motors at all. So it's completely free and outside of all of the structure of the gimbal, and that works fine. So it's a bit of a nuisance though, because what it means is that I haven't really stuck it down anywhere. I probably could, but we're going to see this wire occasionally coming into the view of the camera like this, depending on which way the camera's facing. So that's a bit of a nuisance. So it's totally unrelated to this project though. Just thought I'd mention it in case you're wondering why there's this wire poking out in the camera view sometimes. Right, so what else is there to check? Let's go back to the screen again. We have... Okay, so that's yaw. Left one is the current heading of the quadcopter. The right number is the bearing relative to the quadcopter that the camera should be angled to. So when this second yaw number is 0, that means that the camera will be facing straight forwards relative to the quadcopter. Negative number will be facing to the left, positive number will be facing to the right. So I'm not sure if we can see it there at the moment, but alright, so this is, it's facing almost 90 degrees towards the left of the quadcopter, and I can see right now it says minus 93. I'll see if I can bring it back over here without it changing. Okay, oh, minus 93, good. So that's what that means. So minus 90 degrees means 90 degrees to the left. Alright, so mode. The next line says mode, and I had planned for this to be showing one of the modes that it's in. So it's like fixed radius or fixed offset or overhead, or there's a couple of other modes that I made. But for the time being, all it does is change between 0 and 1 when the follow me mode is engaged. So to do that, again, turn my radio on, and you can see the number 5 changing to 10 at the top, so I'm controlling the roll stick on my transmitter again. And if I turn my switches to the position where this follow me mode should be engaged, we'll see that mode number change to 1. So that is 1, obviously. So that's just telling us that it thinks that it's doing follow me right now. Of course, it's not going to get up and fly because it's not armed, and it's not the flight controller is not in the right mode or anything like that. And finally, the last line on the screen shows the it kind of depends a little bit on what each of these numbers means, depending on which mode that you're using, whether you're using fixed offset or circle or fixed radius or whatever. But they are the offset of, I think it's the let me get it right, it's the target offset from the follow me tag that the quad should position itself at. So in this case it's 0, 0, 500, meaning that it should position itself at the exact same lat and long. So these numbers are lat long altitude. So 0 and 0 means it should position itself at the exact same latitude and longitude as the follow me tag. And the altitude should be 5 meters, so this is 500 centimeters above the follow me tag. And the reason that we ended up with this is because in the mode that it's set to use at the moment is overhead, which means that it's going to position itself horizontally at the same place as the follow me tag, but above it. And this 5 meters is just a safety value, because since the quad and the tag are going to be in the same place horizontally, they can't also be in the same place vertically, otherwise, you know, it might be a bit painful. So that's why it's 500 in this case. But these numbers will change a little bit depending on what kind of mode you are using. Okay, I think that's about all we need to look at for the hardware side of it. And I realize I haven't, explained everything in excruciating detail about every single wire, where it goes and everything. But again, this is not really an entry-level project, so if it seems like the kind of thing that you're going to have trouble with just by looking at the source code comments and reading the GitHub page, then it's probably not the project for you, to be honest. So the other thing I wanted to look at just a little bit, because it would be a pretty boring video if we didn't have some video footage to look at of this thing in action, and I have uploaded some of that before, but I've tidied it up and we have I have a couple of extra modes now, and it's all working a lot nicer, and there's some nicer features to stop the camera from, when you get directly overhead, the camera was rotating like this and going backwards and forwards because it was too close. So if it's here, the camera should point that way. If it's here, the camera should point that way. And if it's just sort of crossing over like that, it ended up turning itself around like this and around like that. So I've gotten rid of most of that kind of annoying stuff. There is still the problem that because I'm using a gimbal, it doesn't go fully around. It doesn't have unlimited yaw to just rotate around and around and around and around like that. So if it's pointing, let's say that's forward, and if the camera's pointing forward, if the target is, let's say this is the follow me tag and it's moving around like this, and this is the quad, this is the camera gimbal on the quad, and the quad is just facing forwards the whole time. It's just hovering, staying motionless. And let's say the tag, so the camera should be pointing at the tag like that as it moves like this. But because the gimbal is not able to just rotate around and around and around, when it gets to, in this case it would be minus 180 degrees, as it crosses over this point here, it's going to suddenly become 180 degrees, and the camera is going to go all the way around like this to point at the tag as it moves around like that. In most of the modes for this follow me mode, for this follow me control, if you're putting it in the GCS nav mode, as we'll look at in a minute, the quad will orient itself to face the tag as well, so you shouldn't have it crossing over this 180 degree threshold very often. But if you're just flying fully manual mode, or in other modes like waypoint or return to home or something, you could quite often get the situation where the arse end of the quad is pointing directly at the follow me tag, and then the camera will still do a lot of kind of sudden moving around like this to get itself in the right place. But anyway, that is actually unavoidable unless you have a gimbal that can rotate in unlimited yaw. Anyway, what was I looking at here? Okay, so yeah, let's have a look at some video that I got of each of these modes. I'll just briefly list them up, mention them here. Turn only is the simplest one, and when you're doing this you should probably start from the simplest one first, just in case you didn't get it right and you have problems. So turn only is basically just position hold, except that the quad will change its heading to point towards the follow me tag. So that's a good one to confirm that the tag is, at least the compass and relative latitude and longitude and everything is correct. Overhead, this one can be a bit scary sometimes. So the quad will move to the same horizontal position, that should be, as the tag, and it will have a minimum altitude enforced as well. So each one of these modes I've described in more detail down below, with a little bit more concise and full definitions of how they work. But I'll just briefly mention them here before we look at the video so that you'll see how they work in each example. Fixed offset will maintain a fixed relative lat long and altitude. So basically it's like if you're holding the quad out on a selfie stick, and then you could just fix that selfie stick in space so that it just held itself and it didn't rotate around anywhere. That's what that one will be. Fixed radius is the quad will maintain a constant distance away from the quad. That's not right, is it? From the tag, that should say. Horizontally. So I think I might just make a little example in Box 2D to show you what I mean by this. It's probably the best way to demonstrate it. Okay, this is an example of what I mean. Suppose the large circle is you as you walk around, and the small circle is the quad. In this case, Box 2D, this is a 2D physics engine, and it lets us, simulate things like this quite nicely. But as I move around, you'll see that if I move directly away or directly towards the quad, it will just move to keep it the same radius away from me. If I move laterally towards it, it will move sort of, hope this is clear, but if we walk in the same direction, it'll end up behind us eventually. So if I go from here directly upwards, it'll at first start to push itself out and away until we get to here, and then it'll stay where it is for a bit, and then as we keep going forward, it'll find itself sort of dragging along behind us. So if you were careful enough to walk exactly towards it, you could just keep pushing it ahead in front of you like that. So the idea is that it's never going to be completely above you, and it's never going to get too far away from you, and it should have a nice sort of a diagonally downward angle for the camera to view you from, not completely from the side and not completely from the top either. So that's the purpose of this fixed radius mode. And finally we have circle, which is where the quad will rotate around the tag. And the radius of the circle for the circle case and the fixed radius case will depend on what the distance was between the quad and the tag when you enter follow me mode. Anyway, so let's have a look at some video example of each of these. I guess we'll start from the simplest case of turn only. Actually, first let's have a look at how the camera behaves with some of the existing flight modes that cleanflight already has. In a lot of these examples to follow, I'm going to start off with the follow me tag sitting on this fence post here. It's a little bit hard to see in the video because it's so small, but most of the time that's where it's going to be. It should be obvious when I go and pick it up where it is in other cases. Anyway, so here I am just flying 100% manually, and you can see that the top of that fence post is pretty much in the frame most of the time. It's a little bit slow to react when the quad turns from when it yaws from side to side though. And now here's an example where the quad is running in autonomous waypoint follow mode. So it's just got a couple of waypoints that it's going to go up and down beside the house. And in this case the follow me tag is sitting on the fence post next to the clothesline, but it's in the same general area as it was before. By the way, there's quite a bit of shuddering and some jello in this footage, but that's not a problem. I mean, I don't like it, but I haven't really bothered to try and get rid of it. It wasn't really the focus of this video, so just try and ignore that. Now there's a couple of waypoints close together at the end of the pass, so you'll see that the camera sort of goes off target a little bit there. And I think I'll speed this up because it's a little bit long, but I wanted to show it all to you, so let's look at it a bit faster. And I run the waypoint track again, and this time I pick up the tag and I walk around with it. So when I do that, it should be pretty obvious from looking at the video when I have picked up the tag and the camera is following me. So the point of this is that the camera gimbal will turn to face the tag regardless of whether you're using any of these follow me control modes or not. So this is manual and waypoint, basically anything, even return to home as well. Of course, when you're doing return to home, it will aim the camera as well. Okay, now let's have a look at some of the modes that are provided by this new controller. First one is turn only, and you can see when I raise the transmitter up like this, I switch it on, and it moves a little bit. It's not supposed to move at all, but it doesn't move much. And then for the rest of the sequence, it just turns the camera without moving at all. So it's like a position hold, but it turns the quad and the camera to face the target. Next up we have the overhead mode, which when I turn this one on, it will go and hover itself over the fence post, and then when I come and pick up the tag, that is, it will of course follow me around overhead. It's a little bit unnerving, this one. I found it a little bit hard to take my eyes off the quad when it's right above you and the noise of the props is so close. It wasn't so bad when it's up high though. Here's an example of how the minimum altitude enforcement works. This one, the quad starts off hovering at about the same height as the tag, and then when I switch the follow me mode on, it raises itself about 5 meters so that it doesn't crash into the tag when it gets there. Of course, if the quad is already high enough, it doesn't need to change its altitude, so it just keeps the altitude that it had already. Here is an example of that, and you can see I've walked out into the field a little bit, so the target location is now different. To finish off this battery, I decided to have a bit of fun and ride the bike up the driveway a little bit just to see how it coped with a faster moving target. I can't go too far, unfortunately, because there's power lines there, but I think I will try this on the other part of the road that has no power lines sometime. It's like a fun thing to do. Okay then, let's look at fixed offset mode. So I'm going to pick up the tag from the fence post, and when I switch into fixed offset mode, initially the only thing that happens is that the quad will turn to face the tag. It doesn't move anywhere. But when the tag moves, it will follow whatever the tag movement does. Next up is fixed radius. This one, again, when I first activate the mode, it doesn't actually move. It will rotate to face the tag, of course. And then after that, when the tag moves, it will move in the same way as I showed you in the Box 2D physics simulation example just before. This particular run turned out to be not a very good demonstration of this mode, but I'll put a link in the description to where I showed this originally a few months ago. I think it would be a little bit better to watch. And finally, the last mode is circle, and when this one starts up, the quad will initially move to the position due north of the tag, as it does here, and it will start to rotate clockwise, looking down from above, around the tag, using the tag as the center of the circle. The speed of movement is supposed to be 4 meters per second around the circumference of this circle, but it turns out to be somewhat less than that because the quad is being given instructions to move to a point and stop, basically, and then that point is being continuously changed, and it's supposed to slow down as it approaches the point as well. So because of all those reasons, it doesn't actually move at the desired 4 meters per second. That also means that the radius is going to be a little bit smaller than it should be, and on this day it wasn't a very nice circle to begin with because of the wind, I think, mostly. On a calm day it does a much better job. Trust me, it does. So that's going to do it for now. I think I'll post this to the RC Groups thread about cleanflight iNav. I think there'll be more people interested in this on that thread than there will be on my YouTube subscribers. But in future, I don't see myself making a whole lot of changes to this. You never know. But if you do have questions, and of course bearing in mind what I said before about asking for help, probably the best thing to do is to ask a comment on this video. Don't send me a direct message because that's not very helpful for other people. And a lot of the time I don't really know which video out of my 300 or so that people are talking about to begin with. It's just kind of a nuisance. And it means that I have to answer the same questions over and over if it's not a public question in the forum, on the YouTube comments. So ask a question on this video in the comments so that other people can benefit from our discussion. And I will update this GitHub README file here with stuff that I've forgotten. I think is probably the best way to go about this. Yeah, so that's all I have to say on this for now. Thanks for watching. Turned out to be quite a long video, didn't it? Anyway, see you later.